Welcome, everybody. Thank you so much for joining. My name is Miss Lynette, and we're talking about all things abacus. I've been doing a little bit of research on the other things that's being happening. So thank you again for joining. My name is Miss Lynette. Okay. And so what was really interesting as I was doing some research on, there's a person that I was following, and they were mentioning on how breaking up a number, and I was like, huh, if they just broke up their number a little bit different, I think it would have been a lot more easier. So let's get into it. So here, let's see. The question is, okay, so the question is, um, let's see, 7 plus 5. So the question was 7 plus 5. And one way they were doing it was very interesting is they would break up the number, they would break up this number. They would break this up into 3 and 2. So there are no other number bonds, which is very interesting, right? And so what happened was they combine these two numbers, and this becomes 10. So then when you bring this down, this would be 2. So we know 10 plus 2 is equal to 12, which is very different in abacus world. Because abacus world, what we do, let me rewrite it. So in abacus world, what we do is we do 7 plus 5. So here, because we want to add the 5, what we do is we say, well, how do we get 5 into 10? So we have 7 on the abacus, like this. That's what 7 looks like. And what our thinking is, I always want to make the second number go to 10. How do I do that? Well, I know 5 plus 5 is equal to 10, right? So we need to know, where does this 5 come from? If you notice, good morning, Alyssa. If you notice, this is actually 5 plus 2. 5 plus 2. We take 5 away from the 7 and we move it to here. So we take 5 away from 7, and that gives me the 10. So I add my 10. And so my answer becomes 12. So what are we learning here? Instead of breaking it up like this, that decomposes, what I'm doing is I'm using the partner of how to make a 10 with this 5. And that's the difference between abacus math and mainstream math. And that's it. How's it going, Elisa?
I'm fairly okay. I think my allergies are kicking in. And I
Oh,
start to kind of feel like I have cold-like symptoms. So I've been trying
yeah.
stuff. Yeah, every time I go outside, I just have sneezing attacks. That
You
like,
know what's really helped me is what really helped me was um putting on a mask.
mm,
That's helped me a lot.
uh-huh.
And so whenever my allergies act up, I'll put the mask on.
Yeah, also drinking a lot of water. I'm making sure I'm hydrated.
Yeah, I drink a lot of water already, and I noticed that that doesn't help me. The mask really helps.
Hmm.
And since we've already gone through COVID, it's not strange for us to wear it.
Hmm.
So,
Yeah. Yeah, I'm taking my homeopathics.
oh yeah, nice, nice.
So that's really helpful.
Oh, good.
I when I get on, I don't click your blue button. I
That's fine.
just I just click the other thing because
That's
I
fine.
think that
As long
that's
as it
easy.
works.
Yeah,
Whatever works.
yeah.
How's
So
it going, Tammy? Tammy just joined.
Oh. It is going. I just finally got my bike for another 42 days.
What happened with another 42 days?
My PT bike.
Okay.
So I was getting that arranged and I looked at the clock and I went, I gotta have this. I gotta go. So,
uh,
so I am back.
Welcome back. So I was talking about how mainstream math is starting to do decomposing, and they decompose the first number.
Hmm.
Okay.
And this is their new way of this is one of the new ways of doing math. So I was just showing how we do it on the abacus. And then the
Hmm.
abacus, we always want to do is always do the second number, always make that to the 10.
Hmm.
That's it.
Okay.
That's all.
Yeah.
And I find it very elegant because you don't have to decompose and then think of what's going on. Because when the numbers get bigger, I don't know what they do when the numbers get bigger.
I don't know either.
Yeah. So I got to do more research on that. All right. So yes, it's going to be, I have 45 minutes left. I'm going to try to keep up with this. Is there any questions you have, Elisa or Tammy?
How about we start with Tammy first?
Well,
Are you sure?
I
Yep.
I've been going through the multiplication problems and the division problems that you had on the community,
Yeah.
and for some reason, ever since the surgery, my brain has been fogged up, and so I've been slowly getting through the multiplication problems, and I'm getting back through them, and I'm like, okay, this is good. And I sent you that one message about the 2604 divided by 42.
Yeah. That was a good
And
one.
yeah, and the answer was 62. And I'm like, that can't be right. And it was, because it just didn't look right when I did it, but it was.
Yep.
So
Shall
now I'm
we
just focusing on the multiplication ones.
the multiplication ones?
Yeah, you put multiplication problems that you put in before the division problems.
I did. Oh, before the division problems.
Yeah,
Okay. Oh, okay.
I'm just going through them and working them.
I see. I see.
you
I see.
you've got you got them 98 with the divided symbol 24. I'm writing them out with it's 24 with the divided problem, and then it's 984 as the divisor. That's not right. I said that wrong.
Yeah, you're multiplying, right?
Well, the dividing problems.
The dividing problems, the big ones. Right. I saw that one. Right.
Yeah, I've got those worked out,
Oh, good.
and I'm working on the multiplication problems.
Right.
So, um, but I had got, yeah, but like this problem here, the 2604 being divided by the 42, and 42 is the divisor.
Right.
I wrote it out. I had to write it out like you've got it written out, like that,
Right.
because it makes more sense written out like that.
Yep.
And it just looks funny
Because it's
written
so
out.
easy.
It is now,
Yeah.
but when first couple times I did it, because I did it like 3 times, because it's just like it just looked weird when I wrote them out, when I worked them out.
Really? Okay.
It did, and I'm just like, and I worked it out on the abacus, and my little one is missing. It's over here in this my little one is missing over there on on my table somewhere. So
Oh
now
yeah.
I've got this one.
Nah.
Um, and but like I said, I worked this problem out like 3 times because it just didn't look like the answer was right. And I'm just like, but the answer being what it came out to be, I'm just like, it just didn't look right. The answer didn't look right.
Okay.
But
Shall we try it?
it came out the same answer.
Yep. Shall we try it?
Sure.
So where do we put our quotient? Alyssa?
I think I did it. Oh, except I forgot to do something. Okay. Okay. All right. Where do we put our quotient?
Yep.
1, 2, 3, 4, and then minus. Okay, so 4. Okay, on this problem, you want to start at the right before the second dot towards the end. You can put your 2604.
We can name it 2. So when
Two.
we count it, this is 1, this is 2.
Mm-hmm. So
So here's my 2. We're going to start at the tens column, and
yeah.
I'm going to put the 2,600.04.
Okay, I was off by 1, but it still worked out. I don't know.
Good.
Although what I did notice is that I didn't put my. Oh, I forgot to put my numbers up. I did the subtracting right, and I got everything. Okay, go ahead. I'm just proud of myself.
Good.
Even though
So
I
what is,
go ahead.
no, it's really good. It's exciting.
Mm-hmm.
Okay, so what are we going to do now?
We're gonna start with the 4, and we're gonna go 4 times what is equal to 26 or
Right.
less.
Right.
So that would be 4 times 6.
Right. So 4 times 6 is equal to 24.
Mm-hmm.
So I add my 6 right here.
Yep. And then you subtract the 2, and you subtract the 4 minus the 5 plus 1.
Good. And then because we do the 4, we
You
got
do
to do it
this.
again to the 2. So
Mm-hmm.
2 times 6 is equal to
Oh, 12.
12.
Oh, that's what I did wrong. Oh, yeah, I have to
So
do the thing. Minus the 1.
and then
You can't minus the 2, but you can add the 4.
no,
Right.
we're doing 12. How do you take away 2 from here?
You have to minus the 10 and plus the 8.
Yes, minus the 10 plus the 8. There you go.
Okay.
And then we're done. So now we're done. No, we're not, because we still have dividends.
Mm-hmm.
So we're going to do it again. Let me rewrite it. Now we're doing 4284.
Mm-hmm.
What do we do?
4 times 2 is 8.
Right? Right. Remember, 0, 8.
8.
So
Mhm.
that means 0, 8. So we add the 2 here.
Oh, okay.
Take away the 8.
Take away the 8.
And then because we did the 2 here, right? Because we
Yeah.
did this 2 goes to the 4. Now we got to do it to the 2.
Then 2
So
times
2
2,
is
0, 4.
0. Yep. 0, 4. So take away the 4.
And then you put up the 2, or you don't put up the 2.
No. We already did the 2. We did
Oh.
the 2 on this one right here.
Oh.
You don't do it again. You did it once, you got to do it again here.
So by showing that visual on paper, it's showing that. Yeah, sometimes I get mixed up. I think I have to write it down. It's just verifying what it did before with the other. Okay.
Yeah, exactly. So you want to make sure that if you did 2 here, if you did 2 here, you got to do 2 again to here. That's all.
Well,
That's
I
it.
did it wrong on paper because the answer is supposed to be 62.
Yes.
Yeah.
I got a totally different answer.
What did you get?
I got 69 because I did 26 minus 24 and I did a 2 and the 0. So then 20. And then you have 18, which is I got 69. I don't know how I did that, but that's what I got.
Because when you were subtracting a little bit more or not enough. Because
Oh.
right here you mentioned that you're going to add the 4. It's like you don't add the 4 because we already finished it. So we're already done with that. We have to subtract the 12.
Oh. Okay, well, I'm glad you could pinpoint where I went wrong.
Yeah. So we did it again. We have 2064, right?
Mm-hmm.
And then we do take away, take away this, add the 6 here, right? Take away 20, take away 4. Take away 4 is what? Minus the 5 plus 1, which is fine. And then, because
That's
we
where I
did
saw the 2-0. That's where I saw the 2-0 right there.
the 2, 0,
Yeah, there's 2
2,
and
and the
then
0.
0. And so that's
Okay.
why I ended up subtracting the 18 from there.
Right. But where do you get the 18 from? There's no 18. 2 times 6 is not 18.
Yeah, now that I realize that you're doing the same number that you did before, yes.
Oh, okay. Right. So 2 times 6, because whatever you do to here, you got to do it to here. So then we
Yes.
do 2 times 6 is equal to 12. So 12 is take away 1 and then take away 2. Take away 2 over here is minus the 10 plus the
8.
8. So
Well,
I
that
think
was a beautiful mistake.
maybe that you have mistaken the 18 with the, because instead of seeing the 12, you thought it was, yeah, there was
What
the,
I realized is that I forgot that what you do with the 4, so you're getting the 6. What you do to the 4, you do the same with the 2. I just totally forgot that, and I thought, okay, well, how many goes into 18? Then I
oh, well, where do you get 18 from?
well, it's because I didn't do that one part. What you do with the 1 is the other, because that's what you do in distributive multiplication.
Where do you get 18 from?
Which back from the 20. Because I made the mistake of not using the same multiple.
Oh, so you just took away 2 from here. 2 take away 20 is 18. That's how you got it?
Yes.
Oh, so you took away, okay, got it. I got it.
And then
Interesting.
I didn't go back and do your principle where what you do with one
You didn't do
digit.
distributive property.
Yeah, I just, well, okay, 18. So I'm like, okay, well, 2 times 9. So, and I realized that I did that wrong.
I see, I see, I
But
see.
then when I went back to the 4 times 6 into 24, which it was actually supposed to be 12, I'm like, well, why can't I do the 2? Because
Wait,
it's,
wait,
yeah.
wait. How'd you get, wait, 2 times 6?
So
Oh,
this is
okay.
I did. What I did is I figured out 4 times what is 26. So it's 4 times 6. So that's what you do to the 4. And then you're supposed to do the same with now you're doing the 2.
Yep.
And I was supposed to put 2 times 6, but I forgot that principle.
Right. You forgot to distribute it.
So basically, I treated it as a separate multiplication. So
Right.
what do I need to do to remember that? When you're saying what you do to one side, what you do to one digit, you use the 6, what is that called? The same multiple? Is that what it is?
I think so. The same multiple. Yeah, it's the same multiple or the same.
How would you word that?
I think it would be the same multiple, the same multiplying factor.
There we go. The same factor. There we go. Thank you.
Oh, okay. Okay, yeah. Yeah. So this is the multiplying factor.
Yep. So my mess up was I was supposed to use 6
And then do
and
six again.
I used 9. So I was not using the same multiplying factor.
Right, but you also did is you subtracted the 2 originally.
Well, 2. Okay. Okay.
Because I don't know how you got 18. Because you said there's 20 here. Why are you taking away 2 here?
Yeah. I don't know.
That's what I'm saying. So what
Yeah.
I'm saying is what it sounded like is you kind of mixed. I had to take away 2 to making it at 8 because we know that 8, right? But then you forgot to take away the 1.
Okay. Yep.
But then yeah, so then it's 8, but then you still got to take away the 1. And that's how you get 84. But you said you were left with 18.
I don't know how I got. You're helping me think things through, so I think I'm good.
Okay. Okay.
Thank you.
So that was the thing is like, yeah, you got it. When you do it you do it. If you do it to one number, you got to do it to the other number.
So you use the same mult. So the way to say that to someone is make sure that you started with the 4. 4 times 6 is 24. You want to use that same factor when
Yeah.
you're doing the 2.
Right. Because it's the same thing if we did 4 like this, right? Times that by what's the answer? 62? 62, right?
Yes.
So what do? We do 6 times 4, 6 times 2.
Oh, wow.
That's exactly what we do here.
And your numbers are right out there. Oh my gosh. 24, 12. Okay. And okay.
Right? So when we're looking at it, same thing. And that's what we did here. Right? 8 times 4 times 2, 2 times 2. We did that here. 2 times 2, 4 times 2, and then 2 times 2.
Yeah.
That's why you really need to know commutative property. Right?
Yep.
And that's why it kind of goes hand in hand.
And that's why I don't mind if we stay on the addition and subtraction until you've got it down pat, and then go to the multiplication and then go to the division.
Yeah.
Yeah.
I'm just proud of myself because I'm a lot farther than I was before because I was getting confused a lot. But I understanding I'm just understanding things a lot better with the problem and how to work it. My biggest problem is still lining it correctly on the abacus.
Okay. Yeah. That one, Tammy, what do you think? Well, what do you do to keep yourself?
I have my finger on when I'm doing the multiplication or the division, I have my finger on the point of where I'm at.
Right.
I've done that too, but I keep on forgetting how to put it on there correctly before you start the problem.
That's what I do. I put my finger right where I'm at when I start.
Yeah.
And then I use it to follow along. And I don't move it till I'm ready to go to the next section.
But don't forget, though, I mean, Tammy's been doing it for quite some time. So it's a lot about practice as well.
It is.
Yes.
Don't forget, it's a lot about practice. And this is like,
I mean, and don't compare to me, sweetie. I mean, like I said, I don't mind if we stay in the adding and subtraction till you've got that down pat. And then we go to the multiplication because in the back in the behind the screens, she gives me problems. So, I'm not being held back.
Okay. Lynette, I was wondering if you can clear the abacus real quick. So if we put our finger at the very end, right there.
Where, here?
Nope, the opposite end.
Okay.
And go over 1, 2, 3.
1, 2,
Right there, right
3.
there. Go back,
Oh,
go
here.
back.
Okay.
That's where I put the 2604.
2, 6,
That's what I
0,
did.
4.
Yeah, that's what I did. And so I'm wanting to know how to place it on the abacus correctly, and that because you put it right where that dot was. You put 2604 there.
This is 1. This is 2.
Oh, bring it down your paper. Okay.
Okay. So when I count, what is it? 42. I'm sorry. 4 minus 2. When I see 2, 1, 2. This is where my quotient is going to sit. Then I put 2 here.
Okay.
That's it. That's all I do.
Ah. Okay.
Because I know the 2 is my quotient. This is where my quotient is. My dividend sits right next to it.
I see. Okay. I like how
2,
you explained that.
2, 6, 0, 4. Yeah. I don't know how the other people do it. I don't understand. How do you know their place values? To me, it doesn't make sense to me.
So this is more about positioning it correctly.
Correct. Yeah.
The place values will speak for itself.
Yes. So like some people are like, there was that one where they do their numbers here, then they do their numbers here. And I'm like, well, how do you know how many quotient you have? I don't know how they do that.
Oh, how they
They did,
figure it.
yeah. How do they figure out what the quotient is? Because when you start doing decimals, right? I don't know how they can decipher the difference.
Where did you get the concept that we're supposed to count? You count the number of dividends
Dividend
are, and then you
dividend
subtract the
and divisor.
divisor. Where did we get that concept?
That was just from what I learned.
Oh, that's what. Okay. What's it supposed to mean? Besides, it obviously shows itself, but I would guess the logic behind it.
Exactly what it is, finding the starting point.
Okay. The purpose is to find the starting point. Okay.
Yeah.
Thanks.
Because the idea is we can premeditate our answers.
Aha.
That's what we do on the abacus is we can premeditate our answers. We know it's going to be 3 we know our answer is going to be 2 digits because we can critically think what it is. Same thing how we do it here. We can predetermine the amount our answer will be. It's going to be somewhere in the 4 digits. Why? Because it's 1, 2, 3, 4.
Okay.
Right? Same
Yep.
thing with division. You could do the same thing. Instead of adding the 2 together, we have to subtract. Because what is the opposite of multiplying is dividing. What's the opposite of adding? It's subtracting. So if you multiply, you can subtract.
Cool.
Right?
You explained that very well.
Thank you.
Yep.
So you have to make sure that whatever you do to one side, right, it's equivalent.
Mm-hmm.
Yeah. And so that's what we do is when we try to figure this out, 4 minus 2, right? This 2 goes on over here because we don't, anyways. So 2 is the starting point. Starting point is to critically think how big our number is going to be. That's all it is.
I like that. I think this is the first time. Yeah, you've explained it before, but then as soon as you drew that line in the paper and stuff like that, then I got it.
Okay. That's why we keep doing it, because there's many different ways of explaining it. We just got to find that one way that makes sense. See, that's what I'm saying. That's what it is like it's the same thing, but find a different way of explaining it. Not let's do one strategy and do it completely different. And I'm like, no, don't find another strategy. Keep the strategy, just find another way of explaining it.
Will you explain the why behind that? In positioning or finding the starting point. So now, can we do another division problem?
Of course.
You want a double digit or you want a single digit? Because I got them all written down that she gave me.
Let's do double digit again.
All right, we got 3880 divided by 97.
Oh, Alyssa, did you take a look at the right start thing? How did it go with your friend?
Okay. With my friend, I did bring the other the abacus, and I did bring my book. And she was getting it. It's just that I want to be clear as mud when I'm explaining and not be really nervous, because all of a sudden I just still got nervous again. So that's why I asked the questions I asked, because I want to use your verbiage. Notice this. She picked up on the pattern. She wanted me to show her how to do multiplication. I'm like, we're not going there right now. Because I don't want to make a fool of myself on that. And I would probably talk to, but you said something, and I'm going to go back and I'm going to take notes, because you did a comparison. That very top thing that you were talking about is amazing. Because you got, yeah. So I'm going to use that, and then I will bring my abacus again, and we'll do a multiplication problem, and I'll do this very same multiplication problem with her. So, she said that her son kind of thinks that very same way. And I think if I, just kind of bring my abacus and we can work on a couple of problems. She seemed, because she automatically, because we were doing up into a 2-step or two chaining, and she got it.
Good.
And I didn't even explain that there's 2 chaining at all.
Yeah. Chaining, just chaining.
Just chaining. I just need to feel confident in myself.
Okay.
Yeah. So,
and how is it? So did you take a look at the Right Start curriculum?
Oh, I have that, but I don't know where the abacus. Once I find the abacus, then I'll do it.
Okay.
I'll do it next week.
Okay. No, I was just wondering, because you said that she knows how to do the Right Start, and was she able to? Are you guys able to compare the difference?
I haven't done that yet, but I will ask her to show me, because I'm not very familiar with that. And even when I show it's confusing. Yours is not confusing. But yeah, once I find it, then I'll turn on my camera and I'll show you.
Okay. Did she find the abacus easier, this way easier than the other way?
I think she needs some more exposure, but I don't.
But she's open to it.
Just she said it made logical sense. So I think if I bring it a couple times and do a couple more problems with her, I did show her your book and everything. So I have her contact, so I can show her on Amazon some of the books. I'll show her the multiplication book that you have too.
Okay. I was just curious about that whole side quest that you're doing.
Yep.
You know what
Okay,
you're doing, I promise.
you do know what you're doing. You just
You
got to
really
feel
do.
confident. Yeah. You're you're not feeling confident, but you know what you're doing.
Yeah. Yep.
Yeah. Don't you're second guessing yourself. Don't need to. All right.
Yeah.
So what are we doing?
Okay. We want to go. We know there's nothing times 9 that's going to give us 3.
No,
So
we
we're
got to
going to,
figure out a starting point.
oh, that's true. So 4 minus 2 is going to give us 2. So we're going to be 2 points, 2 spots to the left of the, the dividend.
One, yeah, 1, 2.
Yeah.
So then
So
what are we
that's,
going to do, Elisa? We're going to put the dividend here. Do you see
Yep.
that?
Yep. I did that
Okay.
on the abacus.
Okay. Tabby?
okay. So now we want to take it and we want to look at it and see what times 9 is going to give us 38 or less. All right. So I vote for 4 because 4 will give us 36. And then 4 times 7 will give us,
Wait.
all right, go ahead.
4, take away 30, take away 6.
Yes.
So then, because we did it here, we got to do it
You're going to
here.
do it there.
7 times 4 is equal to
28, I believe. Yeah. So the quotient is 40.
yep,
That was another one that freaked me out.
how easy it was.
Yes. I was like, what dang?
Yep. I'm feeling really good about my division book.
Yes. That was another good one.
Yeah, because it looks scary, but it's not.
Exactly.
Oh,
Exactly.
that's what it was. It was 90. Oh yeah, it was 91. 91 divided by 7. Okay. Elisa, are you ready?
Yeah. Uh-huh. What are we
What'd you
doing?
get? What'd you get?
I got 40.
Okay. That made sense?
Yes.
Easy, right?
Yeah.
See, that's what I'm saying. Let me help you curate the questions.
Mhm.
So that's where we go, right? From here to here. Okay. All right. So that was another thing I found. So I was doing more research, and this guy was talking about how if you do 7 divided by 91, mainstream math, he's saying, he was talking about how the kids should know how to decompose. So if you did, I forget how he did it. He goes like 90 plus 1, that doesn't work. So you did 80 plus 11, that didn't work. And then he's noticed 7 plus 21, that works. And I'm like, you could do that. But in Abacus, we don't do it that way. What we do in the Abacus is what? The first thing we do is we know 7 times what is equal to 9 or less. 7 times 1 is equal to 7. So then we're left with 2. Can we do it?
You're left with 2?
Yeah. 7, 9 take away 7 is equal to 2.
Okay.
All right, let's
Then
do
you
this.
bring down the 1.
Then you bring down the 1. Yep.
And then 7 times 3.
Yep. So it's actually 13.
Uh-huh.
But this is how we do it on the abacus. See how it's broken up?
Yes.
I didn't put it on my abacus right though, because I'm like, wait, because then
Oh, so
I
what is
can't
it
put my
here?
3 on there.
No. Here,
Oh.
what's the starting point? The starting point is 2 take away 1. 2 take away 1 is
2.
1. So we're over here.
Yeah.
91.
Yeah.
Don't forget 0, 7, 0, 9. So you put the 1 here. Take away 7.
Yeah, I do. I subtracted correctly.
No. 0, 7. 0 pushes you over here. We had 91. Your quotient's going to be here, right?
Mhm.
Yeah.
But the problem is it's single digit. 0, 9. So that pushes you over here.
To place your quotient.
Yes,
Can you explain why it pushes you over there?
because we're now dealing with double digits. You always want double digits, even though it's a single digit. Recognize the 0, just like we do it in multiplication, right? When we do multiplication, we do 7 times 1. 7 times 1 is not 7. 7 times 1 is 0, 7.
Mm-hmm.
1, 2, 3, right? 1, 2, 3. What happens? 0, 7. So you put 7 here.
Yeah, because it's really representing 70.
Exactly.
Yeah.
This is
See,
the same
I
thing
had
with here.
placed it. Yeah, I see. I placed it wrong. Okay. Okay.
No, is it you placed it wrong or you don't remember to make the 0? You got to remember to add that 0 and recognize it. Recognize that there's zeros there, so you move it over.
Yeah, that's the part that I'm having a hard time understanding. So you have to go, yeah. So yeah, I placed the problem correctly on the abacus.
Yes.
I
Uh-huh.
did that correctly, but then
When you multiply it out, when you divide it out, it's 7 times 1 is equal to 7. 7's a single digit. You make it a double digit. If I make this a double digit, then it follows the dividend. The dividend follows, right? So 0, 9, 0, 9. So my quotient will be here. It pushes me out to this side.
okay.
But now I thought that's why when we figured out where our starting point was, we came out with 2. So we
No, it
started
didn't
out
come with 2.
2.
No, because this is 2.
91.
This is
Oh, we're
1.
dividing. We're dividing. We're dividing. Never mind.
2
I
minus
had
1.
multiplying.
Yeah. Well,
Yeah.
yeah.
All right. I was in the wrong method. I was in the wrong what we were doing.
Mhm. So you have it placed correctly because this is 1, that's 1, right? We put 91. But because if you have to remember, just like in a multiplication, when anytime it's a single digit, you got to make it a 0. You got to recognize the 0,
The leading 0
the leading 0.
or
Yes.
trailing 0. I can't remember one or two.
Trailing is at the end.
Okay, so that's a leading 0 right there.
This is a leading 0. Yep.
Okay.
So when we do 1, it's not 1, it's 0, 1. 2 is 0, 2. And keep going. 3 is 0, 3. 0, 3, not 4. 0, 3. 4 is 0, 4.
I got that part.
Okay. So you do it again with division. If you do it for multiplication, you do it for division. So
Okay.
now the answer, the dividend is actually 091. Count it. 1, 2, 3, right? 3 minus 1 is equal to 2. 1, 2.
Yeah, and 1, 2 means it's going to be a two-digit quotient.
Yes.
And the reason why you said 0.9 is to know that it's what?
I say 0.9, so I know it's going to be two-digit. Right? Just like here, what do? We counted 1, 2, 3. What does that mean? 0, 7, 0, and then 21, right? This is what we do with multiplication.
Yes.
So we say 0.9 because I know with my 7, it can go into 9. So that's why I do 0. If I cannot divide it, then I don't need to put the 0.
Oh, because it would have been too big.
It's either too big or too small.
Okay.
Yeah,
right.
my dividend would be too big.
Okay.
Right? Because if you notice, 9 times 3 cannot work.
Correct.
You made a double digit, didn't you? Same thing. 7 times 1, 7 times can go into 9. You need to make this a double digit.
Okay.
To make it a double digit, you got to put the 0 in front.
Okay.
You don't want to do this, right? Making a double digit. You don't want to do that because it's too much. We're taking one number at a time. I can put 7 into 9, but 7 into 9, you need to recognize that 0. Or else it's going to be 103.
I have trouble with that myself, Lissa.
Okay. You're getting me? I'm getting it. I'm wondering if that leading 0 has to do with the place value of the problem itself. So that's what I'm wondering, because I thought I got it, but now you added something else. Because today I was sitting there wondering, when they go and they multiply that out, you add a 0 here, and then like if you move your hand, how you did the problem out, raise the paper up. No, yeah, right there. You have zeros. 1 times 0, you have the 0, and then 1 times 7, doing out, in mainstream math, do they tell them what those zeros represent in the problem? And you're kind of also explaining that on the abacus, what that 0 represents. Because my first question was making sure that I position the problem, line it up correctly on the abacus. And then we went to the single digit one, where the divisor was a single number divided into the dividend. And then I got stumped.
Right.
So
it's just like when we talk about this one. So this is where we go into the multiplication, right? And we talk about 49 times 2.
Mm-hmm.
Do you remember this? So 49 times 2, we know 4 times 2 is equal to 8. 8's a single digit. It's not the way in mainstream math. The reason why is because they don't do left to right. What they do is right to left.
Aha.
So if we did it in mainstream math, we did 49 times 2. What do? They do 18. So 1, 8. No, they don't. They do 1, 8. Right? 1, 8. That's what they do.
They don't have an 8 there. They have a 0. 2 times 4 is 8. They'll have a 0
No, no,
there.
no. They don't do 2 times 4. They do 9 times 2.
Oh.
Right?
Oh,
Because
okay.
we do this one first and then we do this one. Right?
Oh.
That's the old way. The old way is they do this first.
Do they? Oh, you probably got me thinking to always go to. Okay.
Right?
Does it
So
really make a difference?
Well, no, it doesn't make a difference, but this is how we're taught.
Okay.
But still, even if you did 2 times 4, we know this is 8 and then 0,
Yeah.
right? And then we
Uh-huh.
know 9 times 9 is equal to 18.
Ah.
And then
Okay.
what do? We add it together, 98,
Okay.
right? But the difference is on the abacus, we are premeditating the answer. In
Yeah.
abacus, we do what? We know 4, 9 times that by 2, 1, 2, 3. We think it's going to be 3 digits.
Mm-hmm.
So then we put it on the abacus. But in order to explain, to move it over 1, right? Because if you did 3, if we did 2 times 4 is equal to 8, your 8 would be here. That's incorrect.
Right.
Because what are we doing here? 4 times 2 is equal to 8. It's actually 40 times 2 is equal to 80. But that means what? If I predetermine this, I put 8 and 0. I don't want to do 8. Oh, I don't want to do 8 and 0 here. You have to change this to a double digit.
Mm-hmm.
This turns into a 0, 8. So instead of having it here, it goes here.
And that's why you have your 080 on your paper there?
Yes.
Okay.
Because let's take it one more step. Let's do 4 times 4. 4 times 4 is 16. If 4 times 4 is 16, what happens to this? It goes right here. Here. 4 times 1 is equal to 4. This is my 10s. This is my 1s. 4 times 2 is equal to 8. What happened here? 4 times 3 is equal to 12. 1, 2.
Okay, I see on your paper.
4 times 4 is what? 16. 1,
Mm-hmm.
6. What happened to my 0? 0 is that placeholder that we need. Recognize the 0.
Aha. I like that. Okay. Thank you.
Does that make sense?
Yes, when you did that, it did.
It clicked, right? Because see, that's the thing. That's the difference between abstract learning and I don't know, abstract learning. We know what single digits are, but when you line it up on the abacus, you need to know 4 looks like that. What happens to our 10? Nothing. When we count 4 times 3 is 12. 1 and 2.
Uh-huh. Okay. All right.
Okay.
Yes.
And that is time. That is good. It's a good ending right there.
Now you answered a lot of questions. So
I did. Okay.
yeah, I will probably ask you those questions again. Tammy, so where did you feel you got stumped?
What do you mean?
That one part when we were basically explaining the zero and the positioning and stuff like that. Yeah, you
I
did.
just, it's just an automatic for me.
Okay.
I don't need to write the zero because I know it's there.
Yeah. You just need to know to move your finger over.
Okay.
Yeah, I just know it's there. I don't worry about it because I know it's there.
I guess I'm asking the whys.
Good. Ask the whys. Ask the whys.
Ask
And
them.
then,
And
yeah.
then probably after a while, just, but that really clarified a lot. We're just so used to, you do the problem, 4 times 1 is 4, 4 times 2 is 8, but
Yeah,
now
exactly.
you're showing why the zero is there. And
But that's why she's teaching it like this.
yep, I
Yeah.
like it.
Yeah.
Okay,
This
this
is,
is gonna be a top video for me.
yeah. So yeah, exactly. This is why I teach the way I do, because yeah, we were like this. We were taught 880, right? But abacus is
Yeah.
so, it's the reason why we do it on the abacus, so then we push it over.
Mm-hmm.
All right.
Well, thank you for explaining the whys, because now I'll be able to explain it a little bit better to Abram
Of
too.
course. Yeah, of course. And that's the biggest thing, is understanding the whys. Once you understand the whys, it's a lot easier to, but again, students don't necessarily need to know the whys, because it will go through one ear and out the other. Some of them will understand it, some of them won't understand it.
And
I
it
think
doesn't
they'll
bother
pick up
me to go over it. So,
yeah, they'll pick up a little bit. I mean, this is not has anything to do with math, but Abram wanted to know how to spell leaving. So
Leaving,
yep, I could spell it Leaving. But I wanted him to remember, first of all, what's your base word? Your base word is leave.
right?
You're just replacing the E and adding the ing. The
Yeah,
E, it's
okay.
basically how you use the word. What is leaving? And what's the difference between leave?
yeah,
So it's kind of like your zero. You want to know that I'm leaving, or you will leave. That,
right.
that you can't, and first of all, in English, you cannot spell leave, which is a verb, Leav, because English words do not end in V. And that's where you have the roll of the E at the end. So, um, and so you're just kind of, I know that's kind of like in English, but you're explaining me the whys for why the zero is the place value, why it's holding, and what's its purpose. And
Mhm.
so I love this. There was just different things, different angles, and I am proud of myself because I've gotten a little bit farther. I was able to follow you a lot better, and so it was awesome. So
Cool.
It's exciting. It's exciting when you get it. It's exciting when it all finally clicks. But it does take time. Don't forget, it does take time to unlearn a lot of things that we're going through.
it does, and that's why I don't think I don't. I think you can, in my personal opinion, I think you can explain the why, but you have to do it, like you said, gentle.
Yes.
And so I have a tendency to do explain to Abram a little bit of the why.
Good. Good.
And it may
Explain the
go
why.
out the one ear or the other, but then all of a sudden he's going to be like, "Wait a minute,
Yeah,
my mom
exactly.
just told me this."
Hmm.
Oh,
Explain the why. Explain the why.
okay, yeah. And then
Explain the why.
And then it will be like what Tammy said. I don't need to know that the zero's already there. It's that you've gone to that, what she was talking about, starts to become automatic.
Automatic. Mhm.
Okay.
Yeah.
And the
To
whys
me, it's
are,
automatic. I just know it's there.
yeah.
Yeah.
And so the whys have been answered for you. And then your fingers start doing the magic on the abacus. So,
Yes.
but so I really appreciate this. I'm going to come back to this, and because what I need to do is go back to the videos and take some notes, but this one was really, really good.
Okay.
Oh.
Thank you. I appreciate that.
Yep.
But that's the thing. That's what I'm thinking. Like, it's not that we need another strategy. It's just that we need another way of explaining what we're trying to do. And I think that's the one problem that mainstream math has is they're like, oh, you don't get it? Let's try a different way. And it's like, no. Understand what they're having problems with and try to find another way to explain what we're trying to do. I don't know.
Because it could be that you're not, if they're not understanding it, it could be that you're not explaining it clear enough for them, and they're not getting enough practice. But that part of their scope and sequence is to go through this strategy. You go for it so long, and then probably you haven't been through that enough, and then you put on a different strategy. And I think you just deal with cognitive overload after a while when you're doing so many, but you're not necessarily doing a different strategy. You were using the same strategy, and you're explaining at a deeper level how it's working. So, and if I'm not understanding something, I'm asking you the right questions, because then you're going back over it again, kind of breaking it down even more of what the roles are for the numbers.
Right.
That's what you're doing.
Right. And like the reason why I go back to it is because there's this little thing. And so I feel like that this is another strategy where they decompose the number. Whereas before, I can see why they're doing it this way.
It's not
But
bad.
obviously, it's not bad. It's not bad. I feel like it's a little bit verbose. But I have to remember they got from here because we were memorizing 7 plus 5 is equal to 12. So I have to remember that nobody knows it this way, whereas we know the complements of 10. We understand how to make a 10. And what we do in Abacus is we always want the number that we're adding to be the whole number of 10 or 5.
Mm-hmm.
So,
yeah, because you're using 5 and 10. Here they are using the partners to 5.
They are, but they're separating this, they're decomposing this and not using the natural what they have already.
Okay.
And that's the difference. And I feel like they're almost there, but I think pretty soon they're going to realize that this is the method that they're going to start using. And I feel like maybe another 10, 20 years, depending on how fast my abacus can grow, they're going to start realizing that the complements of 5 will really hand it very well to make the 10 as opposed to decomposing the 5.
I don't think it'll be 10, 20 years.
I don't know. It's the world. Yeah, let's see. But the idea here is use the 5 for what it is, as opposed to break the 5 for what it. Yeah.
Yes, I can see the concept, but you also in your book tell what the making of the 5 is, which is 1 and 4 and 2 and 3. You
Right.
mention that in the book.
Right. But I don't use 2 and 3 I don't use 2 and 3 from this 5 because it's not part of the equation.
Okay.
That's the difference, right?
Mm-hmm.
I'm using the equation 5.
Oh, got it. I like it.
They're doing another step and then they calculate it. That's different.
Yes, it is. An extra step.
And I feel that's what I'm saying. I feel like that they're very, very close, but they're just not there.
Well, we'll give them some credit though. They're very close.
they have come a long way, I'll tell you
Yeah.
that for sure, but I
Yes.
feel like the way it's being implemented, I think confuses the kids. It would really confuse the kids a lot more if they don't have that strong number sense.
Okay,
Yeah.
makes sense.
Yeah.
Makes sense.
So that is time. Thank you again, everybody, for joining.
I'm proud of you
Yeah.
Yeah.
on your time. I'm proud of you.
It's
I
gonna
mean,
get
I'm asking questions. I'm always asking questions, but you've answered them all well. So this is
it's
something
it's
I'm gonna go back.
it's gonna get a little bit more strict because I actually might have a class at 10 o'clock.
Oh,
So
Okay.
so I don't know when the class will start, but I'm not sure, but we'll see. All right.
We'll help you work on it.
Yeah.
okay.
There you
So
go.
thank you again for joining, and I'll see you guys all next week.
Okay,
Yes.
thank you.
Bye.
Bye-bye.
Bye.